All right. Hello, everyone. Wow, those are blinding lights. I hope everyone's doing well. Welcome to Challenging Bias, so developing an intersectional framework for AI and deep learning. I know it's the last session before our keynote or our end note. It's Friday, so I'll keep it short and sweet. But today I sort of want to walk you through a conceptual framework that uses synthetic data to mitigate bias in technical systems like facial recognition. A little bit about me. So my name is Kimberley Paradis. My background's in computer engineering. I've worked a little bit in sort of the makerspace area in robotics. And now I'm a research coordinator with the AI Society Initiative at the University of Ottawa. And I'm also a law student there. So before we start off, there's no one-size-fits-all universal remedy to bias in AI. We talk about bias a lot. It's been a conversation in the last few years, but there is no one solution to it. But we do have a role as software developers, engineers, computer scientists, all of these technologists to try to find at least parts of solutions that can help mitigate the bias. So bias comes from just a whole different areas, but the main three that I'm going to talk about today are missing data. So that's when you either have a segment of a population that doesn't exist when you're training an artificially intelligent system, a facial recognition system, you're actually missing a whole population. And we see that a lot if you think of facial recognition and people who have darker skin. Often they are missing from the training data, and therefore these systems don't actually work with them. We've seen it through a lot of different systems. One example is the soap dispenser. So it was found a few years ago, when those automatic soap dispensers started being popular, that they actually didn't work on people who had darker skin. And it was only when somebody who was white and had lighter skin was used to using it and one day had on like black gloves and just wasn't able to do it. I think they worked in like construction. They noticed that all of a sudden it wasn't working when typically it did, that finally there was sort of like a reckoning that it actually only worked for part of the population. Another source of bias is human bias. So humans, we have prejudice, we are biased. And that actually just ends up getting baked into whatever system we're creating. A really good example is the Compass software in the United States. So they created this software. It was a recidivism software, and they wanted to use it for people who were incarcerated in jail when they were up for parole, and sort of automate deciding whether or not they would be up for parole, whether they would be granted. So what they did is they would sort of input all the information about the person who was incarcerated, and then the algorithm would spit out whether they were likely to reoffend if they were let out on parole, if they were likely to commit a crime again. And that seems like, okay, the criminal justice system, it's backlogged, at least in North America. Maybe this can be kind of okay. But when you actually look at the history of the criminal justice system in the United States, Black people, Indigenous people, queer people were likely to get harsher sentences, to be incarcerated for things that other privileged people, like white people, were not going to. So what this software did was it just took all of the bias that the judges had accumulated over centuries, and maybe exaggerating a little bit, but over a very long period of time, and just spat it out through an algorithm. So it wasn't perhaps the actual algorithm itself, it was just what it was trained on from us humans. And the last piece is sort of the feature engineering piece, which is sort of the harder piece to conceptualize. But that is if a feature is chosen to be part of your system that actually does create sort of a bias itself, not through the data, but through this feature that you're adding in. So we do see it a lot, let's say, with credit scoring systems. Let's say you want to buy a house in this economy. If you can buy a house, we can have a chat after. But they will look at your education, let's say, and now you have to think, okay, well, you look at education, yes, maybe that makes sense. However, who doesn't have access to education or to traditional education. And now we're seeing even more. I'm sure there are a lot of people at this conference who don't have like the typical engineering background, but they are very well trained. You have a good job, you have all of the other criteria, but this one specific one is so rigid that it actually ends up entrenching more bias into these systems. So it's really important to look at sort of the causal and contextual factors, right? So it's not black and white. One of my favorite examples is if you were giving a data set, creating a data set where you looked at people's education level and their height. There's no real causation relationship. If you're taller, you're more educated. But if you were actually to assign it to an entire population, let's say all of Norway, the algorithm would tell you that taller people are more educated because they would take into account that a 5-year-old doesn't have a high school education, an undergraduate degree, a PhD. They're 5, but they're short. And so they would sort of bring that together and have no other context to say, okay, well, developmentally, a 5-year-old can't write a thesis. That's just maybe later on, but their height has actually nothing to do with it. So that's why it's super important. And when we look at these, biased systems in artificial intelligence, we have to look at other factors that are not just the ones that we see right away. So facial recognition is sort of what I want to focus on today. We've been talking about it a lot. I think it's coming more to mainstream media now, but it's become very pervasive. We have it in our everyday lives. I took multiple planes to get here, and there were multiple times I didn't show a boarding pass, didn't really show my passport. It was a facial recognition at the airport. So it is becoming entrenched in our day-to-day lives. But it is also very biased. There's a U.S. Sort of activist, computer scientist, Joy Bulvami, who was doing, I think, her master's and was playing around with facial recognition a lot and just noticed as a Black woman, it wasn't really picking up on her face. It wasn't recognizing her as well and could never really put her finger on why. And then one day, it was after Halloween, she had the white mask you can see in the picture, and she just sort of like put it on and then tried the facial recognition software, and it immediately picked up on her face right away. It was a white mask, and all of a sudden it made all the difference. And she sort of started studying facial recognition more deeply then. And one of the main issues that was sort of came to her attention was that there was a lack of training data, which we spoke about a little bit earlier. So there were less Black faces that it was being trained on. So when the algorithm had a Black face and had to do something with it, it actually just couldn't pick up on it. It hadn't been trained. And that also happens not just with race or the color of your skin, but we've also seen it during the pandemic happen with disabilities. So in the pandemic, a lot of students have had to use facial recognition technology for examinations, evaluations, things like that. And students with disabilities that show up on their face, like Down syndrome, they actually weren't being recognized either. Now, this might not sound right now like the end of the world, but it is just this added layer for all of these different groups who are just not experiencing the same technology that, let's say, I would, or the other people in this room would. They're experiencing differently, and they're actually just maybe not even experiencing the technology at all if it doesn't work. It doesn't realize that, this is their face, and that is just how it is. So, how do we source data? There are 4 main ways. There are others, but these are the main ways that are used. So the first one is public face image data sets. So when you want to create a facial recognition system, you might just go online and sort of pick one that's open publicly. There's one that's called the Celebrity A. And so it is just a huge data set of celebrities. Think Hollywood, everyone there, they're on this data set. And you can just get that online. The other one would be crowdsourcing. So there's actually apps where companies can go in and say, okay, I sort of want, I'm creating this facial recognition system, I'm looking for people, and then you and I, anyone can go online and just take selfies, take pictures, and provide that data to these companies. And what they'll do is they'll ask you, okay, like we want one picture of you just forward facing, one on the side, one on the other side, one smiling, one looking sad, one looking angry. And then you just submit all of that, and then companies can pull that data from there. The third one is automated data collection. And that's sort of what we're seeing with web scraping, where companies, especially ones with a lot of resources, when they want like a huge data set, they'll just scrape like all of the internet. So there's different softwares that you can use, and they'll just pick up everything that exists online for these different faces. And that's often, like I said, they want really, really huge data sets because it's an enormous amount of data that they're about to get. And the last one is in-house data collection. So if a company wants something very specific, very unique, they might decide to do it themselves, and they might use a combination of surveys or crowdsourcing, but from a specific population. They might use maybe a combination of a few of the ones I've mentioned before. This one is a lot more expensive, so it's used less, but it can still be very relevant. Now, it seems like when we have all of these options, if we know there's a bias, so if I'm creating this new facial recognition application, I know there are biases. I know that I can, go and crowdsource. I can web scrape. Maybe the solution is just to get more training data, to just pay attention and say, okay, it's not working. Facial recognition is not working on people with disabilities. I'm going to make sure that we compensate for that and have more people, and I will pay attention to this specific population, which does work. It is one solution. But what I want to propose and talk about today is actually looking a little bit further than that. So we have the iceberg. At the top, we do see the underrepresentation of training data, which is important. But why? Why do we have this underrepresentation? We're going back to sort of the contextual factors that I spoke about earlier. So one of them, if you think of the crowdsourcing, there's the digital divide, right? So not all populations have the same access to cell phones, to the internet, to all of these different things. And so if you're going through crowdsourcing, you're actually not accessing, and it could be like an entire geographical area that just doesn't have access. It can be an entire group that you want to, and you will just not be able to get that data. There could be Eurocentric beauty standards. So, think of like Western Hollywood, they'll kind of look the same in all of these movies. That's another issue, because if you're using, let's say, the Celebrity A database that I talked about earlier, you're more likely to have a very homogeneous population. Same thing for the lack of representation in media and the socioeconomic factors. There might also be sort of a fear of technology. Certain populations are more reluctant to use technology. There are the older generations who, have become very good, can use their iPads, can do all of these things, but they're not necessarily going to go on an application to take pictures of themselves to submit for facial recognition training. So you're actually missing out on this, aging population that will not participate. And all of these things are sort of, what's under the iceberg of the underrepresentation of training data that when you don't consider, you might actually be missing out. So what do we do with sort of all of this information that I'm throwing at you? So we have what are called critical theories. So I'm sure a lot of you have heard of them. Critical race theory has been very discussed lately. There's gender theory, queer theory, and all of these are just ways of sort of understanding and questioning some of what society does. So policies that exist, different cultural aspects. And so by integrating these into technology, what we can actually do is wonder how technology is sort of reinforcing these structures that we are now questioning. So when I spoke about the Compass software earlier, the one for incarcerated people and recidivism, we're sort of having a moment where we're saying, okay, we're using critical theory to think about the fact that, people are incarcerated at further rates if they have a certain identity. How now is technology reinforcing that? And what can we actually do to sort of mitigate that on the technology side using research that's been done by social scientists, by lawyers, by policymakers that already exists out there? So what we can start doing is using synthetic data. So synthetic data is sort of man-made data. You go in, you create it yourself, and it's often used because it's honestly cheaper. And so companies have started to use it because it's easier. You have a little bit less maybe than real data, but sort of think of it as a way to complement sometimes. What we can do now is use the synthetic data to actually evaluate and turn those critical theories that we're talking about and add them into training data sets. So what that does is you could say for the Compass software that I spoke about, the recidivism one, you could say, okay, well, now we know that, racialized people were more likely to be found guilty or to be given a harsher sentence. How do we integrate that into the training data so that by the time the algorithm is sort of learning from our data, it's able to say, okay, well, this data is telling me that actually this person is very likely to reoffend, but on the other hand, I'm learning that this data also was impacted by human bias in all of these different ways. And we can also do the same thing in facial recognition. So we can say, okay, well, we actually didn't have a huge amount of representation of these populations. Therefore, I need to learn to better differentiate or recognize certain aspects that I have not been trained on. And now I'm speaking like this system is actually able to think on its own. It's not. But what you're doing is just giving it sort of more context and a bigger understanding of what is at play. Obviously, you can't offload an entire sort of cultural phenomenon, but what you can do is sort of give it more input data so it can make more context-specific decision-making and then hopefully reduce some of the bias. So, yeah. The way that you can go about this is contextual labeling. So what this means is you're actually attaching labels, metadata to specific instances. So you're saying, okay, gender stereotypes. A lot of algorithms like ChatGPT, I know it's a huge area for discussion right now. If you ask it, I forget what the exact prompt was, but it associates, nurses with being women, and it associates doctors with being men. And so if you were to retrain a sort of algorithm like that, you could attach a sort of metadata to say, okay, this is what a gender stereotype is, and actually teach it before you're training it, rather than ChatGPT now going in, receiving the prompt that, it's a nurse, she is a woman, and then afterwards going back and saying, well, no, actually, nurses are not mostly women, we don't attach that stereotype anymore. So you're retraining it from the beginning. What that looks like in terms of facial recognition is image one is a woman being searched. It was part of a huge campaign in the United States again called Shopping While Black, where people really discussed what it was like to shop as racialized people and how they would be followed around stores and watched carefully, or always assumed that they were stealing and have their bags searched. And this is one specific picture of it. So here, it reflects common racial bias that people experience. So when you are attaching this synthetic data, that's when you would go in and sort of include, over surveillance. And you could create all of these different tags to explain this phenomenon, to train it differently. And then on the image two, you see very nice, very friendly looking interaction. And you could also label that on the other end as a stereotype that all is well. This white woman is shopping, and there are no issues. There is no threat. There will not be any sort of stealing of any kind, and also label that. So it's not even just about correcting the wrong instance, but also correcting the instance where there is an assumption that is positive. You go in and sort of correct both with the synthetic data to level it out and actually give the machine a full understanding. So obviously there are a few challenges. Social concepts, translating them into a machine, into a technical system is very difficult, because not only is there just so much to consider, we broke it down, critical theories into critical race theory and gender theory today, but then it goes even farther than that. You'd have to break it down into even smaller pieces and attach all of this synthetic data into the real training data that you're using. And the other thing is that there are different cultures, different regions. Things I talked about today as a Canadian, as a North American, may not apply in Norway or in Europe or in Asia. It's so different. So that is definitely one issue with sort of taking this approach. The other one is ethical considerations. So looking at this, as soon as you're playing around with people's identities, people's lives, and really sort of not rewriting them, but sort of, that's also a huge, ethical question. How are you doing it? What are the methods that you're doing with it? And there's been a movement to sort of have more governance of technology, of internet, of artificial intelligence, and this would have to sort of be put into that as well. How do we do this ethically, and how do we make sure we're not just rehashing bias in a different way? And then human input, again, it will always be something to consider. But let's say I'm creating this system now. What's to say I don't include other different bias? What if I don't include my own? I say, okay, well, actually, I don't think this is bias. There's still a human or humans and people behind this that you have to consider, because there tends to be a sort of approach where we think we're fixing AI when we do it, and sometimes we have one sort of solution and we use it as if it fully saves our AI or fully makes it ethical, and it will never be, and it requires sort of an iterative approach. But that's something that we need to be considerate of when we're actually doing it, that it's not going to fix everything. All right, like I said, short and sweet, because I know it's the end of the day. Thank you so much for listening. I know this was a more sort of conceptual rather than a lot of the live coding that we've seen at this conference. If you have any questions, I can't see them because of the light, but please feel free to ask them. I will stick around, and thank you so much for coming.